Hello dear students, welcome back to BYJU'S Exam Prep. Now under this series, Concepts and Shortcuts in Linear Algebra, we are discussing different topics. I started with elementary matrices, then I taken 2 classes on determinants, then we completed concept of rank, okay? And topic of today is LU decomposition. I discussed shortcut for LU decomposition, my dear friends, okay? And before starting, this is about me, myself Sridhar Dhulipala. I am having 20 plus years of experience. My qualifications are M.Tech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. And these are my areas of expertise. Actually, discrete mathematics, algorithms, engineering mathematics, programming in C and data structures were recorded by me. See, from past 1 year we were working on a project called recorded content. We try to create visualized content from past 1 year and many teams were involved in that. And under BYJU'S Exam Prep app, the category name is Learn with Video Lessons. You can find these courses. I think already discrete mathematics, algorithms and engineering mathematics are live, and shortly you will be getting C and data structures, okay? Theory of computation is not recorded by me, my dear friends. Remaining all were recorded by me, and you can find these topics, and if you purchase the course, you can access all the videos. Otherwise also, you can access some of the content. I think there is a offer going on. For 7 days, you can access the content for free. Please go through this BYJU'S Exam Prep app to know more details, my dear friends. Okay? Yeah, Vijay Sir, can you tell sin 1 by x continuity and differentiability 3 cases at the end of the class? Okay. Sin 1 by x is a composite function. Okay? Because it is composition of sin x and 1 by x. At x equal to 0, it is not defined. Therefore, it cannot be differentiable and continuous. Rest of the cases, it is continuous and differentiable. That is a simple point, my dear friends. If you have any doubts towards the end, you can ask me. So, let me start with today's topic of interest. Okay? LU decomposition or LU factorization. See, the idea for this LU decomposition or LU factorization is, given a square matrix, you want to write this square matrix as product of lower triangular matrix into upper triangular matrix. You want to write it as product of lower triangular matrix into upper triangular matrix. So here you want to write it as A is equal to LU, where L is lower triangular matrix and U is upper triangular matrix. Okay? See, I just taken the example for 2 by 2 matrix here. There are 2 possibilities here. Either you can use unit lower triangular matrix or unit upper triangular matrix. If you use unit lower triangular matrix, that means the lower triangular matrix main diagonal entries are 1, then we call that method as Dools method. Okay? And if you use unit upper triangular matrix, then that method is called Claudes method. There are 2 different methods people generally discuss. Okay? First, I'll discuss the general methodology for 2 by 2 matrix. Then I'll give you shortcut for finding this LU decomposition. For both, we can have the shortcut, my dear friends. Then we can extend that particular shortcut for 3 by 3 matrix also. If you properly understand, you can extend it for 4 by 4, 5 by 5 or any square matrix also. Am I clear? Yeah. If you have any doubts, please ask me, sir. You can please write your comments, my dear friends. Waiting for your comments. Okay? Otherwise, I'll continue with my class. If you do not have any doubts, let me continue with my class. Hello, good evening. De Villiers, very good evening. Sai Nivas, very good evening. And have a pleasant evening, very good Kruti. Hello sir, good evening. Yeah. So let me start with the class, my dear friends, with the good wishes and good evening wishes. See, the idea is you want to write matrix A as product of lower triangular into upper triangular matrices. In this there are two cases. The first case is with upper triangular main diagonal elements as 1, and that is called Claudes method. The second one is same, you are writing matrix as product of lower into upper triangular method, but here the main diagonal elements of lower triangular matrix are 1 1. We call it as unit lower triangular matrix for convenience, and that method is called Dools method. Mostly this method is used, but it's not restriction, sir. We have to use this method only. You can use both the methods. Okay. So first let me tell you the direct method which generally people follow. Then I'll give you the shortcuts, the easiest method to find LU decomposition without any worry. Okay. So let me start with that, my dear friends. Clear, sir? Very good. Thank you. Now let us see this LU decomposition, because you are using unit upper triangular matrix. You can call it as Claudes method. You can call it as Claudes method. See, this is direct method. I'll give you shortcut immediately after this. This is the method which generally people follow. See, the idea is you want to write a 2 by 2 matrix as product of a lower triangular into upper triangular matrix, because the main diagonal elements of upper triangular are 1 1, and this is the pattern for your lower triangular matrix. If you multiply, hope all of you know how to multiply 2 by 2 matrices. Just multiply. Sorry. First row into first column will give you this, because L11 into 1, 0. And again first row into second column will give you this, L11 U12. Second row into first column will give you this 2 1 element. That is simply L21 into 0, sorry, L21 plus 0. And again this one is L21 into U12 plus L22. So that is the story, my dear friends. Is the idea clear? Now let us apply this for a problem and solve it. First let us understand direct method, then we will go for shortcut. Hope you understand. Clear or not? Now let me explain this with one simple example. Now I want to write this particular matrix as product of lower triangular into upper triangular matrix. I am using unit upper triangular matrix. See, for this method either lower triangular or upper triangular must be unit. That is, their main diagonals must be unit. If upper triangular's main diagonal elements are 1, we call it as Claudes method. If lower triangular matrix main diagonal fellows are 1, then we call it as Dools method. Don't make both one, sir. Either this or that. Here we are using Claudes method where upper triangular main diagonal elements are 1. So this is the idea, sir. So if you can write this matrix as product of lower into upper triangular matrix, the product is this. When two matrices are equal, sir, if the corresponding elements are same. See, my dear friends, it's a very simple rule. Hope you all know it. If you want to say two matrices are equal, the corresponding elements must be same. That is, A must be equal to P, B must be equal to Q, C must be equal to R, and D must be equal to S. So just what you do is compare the elements. Just compare the elements. Then you are going to compare the elements of these two matrices. Then you can easily find the unknown fellows. What are the unknown fellows? L11, L21, L22 and U12 you need to find, and you can easily find it, sir, by comparison. Comparison and simplifications will give you the answer. That is actual method, sir, direct method. So first let me do it by direct method, then I'll give you shortcut. Please wait for shortcut. Okay? Very good. How we will know that L and U matrix, which values to use for a particular matrix? See, it depends on options, my dear friends. Am I clear? But it is also possible that a matrix cannot be expressed as LU decomposition. That is, we cannot decompose into product of L and U also may be possible. Okay? Either depending on the options, or suppose none option is there, you have to check whether that is possible. You have to try both the methods. Because anyhow, I am going to give you shortcut. We can quickly verify that also. Okay? So don't worry, my dear friends. Okay? Clear? Right. Now let us see this. Comparison. Because these two matrices are equal, comparison method means what, sir? L11 must be equal to 2. That is straightforward. Next one, here L21 must be equal to 4. This is also straightforward. Now the comparison for this, L11 U12 must be equal to 1. But you already know what is L11. Substituting L11, that is 2 into U12 is equal to 1. That means U12 is also equal to 1 by 2. Now you found L11, L21 and U12 also. Okay, this is a direct method, sir. Shortcut I'll tell you. Now what you want? The last fellow. So you equate this. What is it? L21 into U12 plus L22 must be equal to minus 1. And you already know what is L21, that is 4. U12 is 1 by 2. L22 we do not know, is equal to minus 1. Simplify this. This is 2. If it send it to other side, L22 value must be equal to minus 1 minus 2, which is minus 3. Now luckily you got every value required. So happily write matrix A as product of lower triangular into upper triangular matrix, my dear friends. So what is A? A is equal to LU 2 1 4 minus 1 is equal to L into U. See, L means what? L11. What is L11? 2. L21 4 and L22 is 3. Sorry, minus 3. Please be careful with the signs, my dear friends. This is general mistake which most of the people do. Okay? Okay, fine. Right. Now what about upper triangular? This is 1 1 0. And now what is U12? U12 is half. So this is how we can reduce or we can express matrix A into or matrix A as product of lower triangular into upper triangular matrix. There is actually a sufficient condition. The sufficient condition is the principal minors are all non-zero, then definitely LU decomposition is possible. But that is sufficient condition. Sufficient condition means if that condition is satisfied, definitely LU decomposition is possible. If the condition is not satisfied, it may be possible or it may not be possible. So generally you can ignore that particular part, my dear friends. Okay. So generally see this. See, for 2 by 2 matrix, this element should not be 0. Generally see that this element should not be 0. Why? If it is 0, you have to divide by this element. This element, if it is 0, division by 0 happens. So that is the bad case. You can easily identify such cases, my dear friends. So generally what we do is a simple verification. Which we do is for 2 by 2 matrix, just verify whether it is 0 or not. If it is 0, it cannot be done. For 3 by 3 matrices, see, we have to consider for 3 by 3 matrices, suppose if it is there A, B, C, D, E, F, G, H, I, then you just check this one, determinant of this one and determinant of 3 by 3 matrices. Actually, if determinant of all these fellows are non-zero, then definitely LU decomposition is possible. If it is 0, some of them are 0, we can't say that because it is just a sufficient but not necessary condition. Am I clear? So that's why I am not getting into that particular condition, my dear friends. Okay. So this is about the idea. Now I am going to introduce the shortcut for LU decomposition. Okay. Yeah. Okay. Let me start with the shortcut. And this is the most important method for all branches. This is the most important method for all branches and especially for computer science students. Okay. And generally this method is introduced by Alan Turing. You all know theory of computation, the father of theory of computation. So they say that he invented this particular LU decomposition for actually solving system of linear equations. Okay. So that is the story, my dear friends. Okay. Now let me introduce the shortcut. Let me introduce the shortcut. Shortcut is very simple. Within no time you will get the answer. Okay. Now let me take the shortcut. Now this is Claudes method. See, Claudes method means the main diagonal of upper triangulars are 1. Doolittle method means main diagonal elements of lower triangular are 1. Okay. That also we can do. First we learn this, then we will go for that. Within no time you will write the answer, sir. What is required? Simple row operations. And what type of row operation? Only third type of row operation. Only third type of row operation is allowed. No other row. For this you need column operations. For Claudes method, you need column operations. For Dools method, we need row operations. Only here, third, or let me put number, third column operation. Only third column operation we can do, sir. Only third column operation. See, my dear friends, this is the matrix, right? And if you observe the lower triangular matrix, this should be 0. Rest of the fellow non-zero. So what you do is you try to make it equal to 0 using third column operation. Strictly third column operation. No combination of second and third. Strictly third column operation. Okay. So how you get it, sir? Column 2 is column 2 minus half into column 1. With this, you can make it equal to 0. See here, fractions, I am working with fractions. You have to do it. Strictly third column operation. Strictly third column operation. So with this, what you are going to get? Here it is 2, 4 because first column we are not changing. But the second column, 1 minus 1 is 0. Minus 1 minus 2, which is minus 3. And you see that is your L actually. After the column transformation, what you got is your L. L is ready. Only you have to write U. All of you able to follow? Bhavya. Good evening, sir. I am unable to attend this class tonight. Can I watch later as... No problem, sir. No problem. See, if you are not able to attend recorded session also you can see this. Because it is a shortcut, even recorded session also you can attend and understand. Okay? And this is a very important shortcut. Generally not available everywhere. Okay? So watch anytime. Okay? So just see the link, keep the link and you can watch anytime, my dear friends. Don't worry about it. Okay? See, interaction means what? Generally there will be very less interaction today because I will be explaining the method. Am I clear? You just need to understand. There are some topics for which interaction is very much required. This because it's shortcut. I am just giving you the method. Because I am not telling you backstory. I am just telling you main story here. Am I clear? So don't worry. Don't worry, Bhavya. A.B. de Villiers. First, let us think about the thing which is happening. We'll discuss all other topics also. Am I clear? I'll come up with more sessions like this. I'll be discussing more topics. Okay. The main purpose is I want to make the concepts clear to you. Okay. And you can please write in the chat or in comment section what topics you want me to take. Suppose you have some particular topic like multiple integrals, like those who are doing engineering mathematics, they have some topics they are very much afraid of, like probability. Any particular topic you can please comment. I'll try to come up with some session on that. Am I clear? So most of the people, if you say that some particular topic is difficult for you, I'll try to come up with one session. Okay, even other topics in the similar manner, my dear friends. It is because engineering mathematics, I am saying about engineering mathematics. In algorithms, some people are having worries about, time complexity. Some people are worried about, recurrence relations. Some people worry about dynamic programming, like that. Similarly, data structures, most important topic is trees. Some people are having trouble with some of the concepts. You can please ask me. I try to come up with some sessions. Of course, regular classes will go on. My complete recorded sessions on discrete mathematics, algorithms, engineering mathematics, programming in C and data structures are already available. They are completely recorded and they are available on your BP app under the category Learn with Video Lessons. Many of our faculty created many other topics also in other branches also. Okay, that recorded content is unique. Okay, it is first of its kind. Visualized content we try to create, my dear friends. I want you to see that and please give your feedback. Okay, thank you. Right, now let us see, let us continue with the shortcut. Now you got this. Now A is equal to LU. L is ready. This is your L, sir. 2, 0, 4 minus 3 is your L. And you know what is U? See, for U already this main diagonal should be 1 and this should be 0. Only one element is missing. If you know how to find it, the shortcut is done. It's a very simple problem. Very simple shortcut. Now to make this element 0, what is the column operation you used? C2 is equal to C2 minus half into C1. There is a minus half, right? If it is minus half, you put plus half here. If it is minus half here, you put plus half here, and your U is ready, my dear friends. Your U is ready. This is your L and this is your U. This is your LU decomposition, Claudes method. And here we are having unit upper triangular. Here we are having unit upper triangular matrix, my dear friends. Hope you understand? Yeah. I think today people are just watching, not commenting, because we had a break in between. Please comment, my dear friends. I am expecting your comments. Yeah, good. So that is about shortcut 1. And again, another LU decomposition we'll try to understand now. If you have any doubts, please do ask me, sir. Please do ask me. Yes, sir. Very good. Sai Charan. Very good. Hope you understand. This is Dools method. In this, you see same LU decomposition only. That is, you want to write matrix as product of lower triangular into upper triangular only. But here, the main diagonals of lower triangular are 1, or you can call it as unit lower triangular for our convenience. And this is called Dools method. Now let us understand this procedure. Even for this, we have shortcut. If you understand, I'll extend this shortcut for 3 by 3 matrix, my dear friends. You can easily solve within no time. You can solve 3 by 3 matrix also within no time. Okay? So let us see this. Matrix A is this. Now you want the LU decomposition, but here you want unit lower triangular. So this is the upper triangular matrix, you want to get it. See, in upper triangular, this element should be what, sir? Shunya. Using row operations, but here remember only third row operation. Only third row operation. Only third row operation you can apply. So what you do is, you try to make this element equal to 0, so that you get upper triangular matrix. You get upper triangular matrix using third type of row operation. That is, using this, you need to make this equal to 0. How you make it, sir? R2 is R2 minus 2 times R1. Got it? Now, the first row as it is, this is 4 minus 4, 0. Now, minus 1 minus 2, that is minus 3. And your upper triangular is ready, sir. Your upper triangular is ready. That is your matrix A, which can be written as lower triangular into upper triangular. This is your upper triangular. 2, 1, 0, minus 3. Upper triangular is ready. Only lower triangular need to be filled. Now lower triangular means what, sir? These two are 0, 1s and this is 0. Only this element need to be found. Now please tell me how you get 0 here. With what operation you get 0 here? With this operation. And here what is the multiple used? Minus 2. If it is minus 2, put 2 here. If it is minus 2, put 2 here, and you got your LU, my dear friends. Hardly how much time it taken? Got it? Sai Nivas, very good. Thank you. Hope you all understood this particular method. If it is clear, please say yes, so that I'll explain the same story for 3 by 3 matrices also. Both Claudes as well as Dools method. If it is clear, please let me know. I'll explain both Claudes as well as Dools method for 3 by 3 matrix also. Story is same, sir. Whether it is 2 by 2 or 3 by 3, story is same. Waiting for your comments, my dear friends. Please discuss one more time. Oh, okay. Let me rediscuss this quickly for our ABD Villiers. What is third row operation? Oh, see dear, there are 3 types of row operation. First one is interchanging 2 rows. second row operation is multiplying row with a non-zero constant, and third row operation is this. Third row operation is this. That is adding constant multiple of other row. Adding constant multiple of other row is called third row operation. See my dear friends, I taken a topic called elementary matrices. In that I explained elementary row operation as well as column operations. I request you to please go through that particular lecture where I explained the row operations, because for this topic that is a prerequisite. Suppose if you understand what I done here, you don't have to go there, but if you don't understand what I done here, you have to go back to that lecture, sir. Am I clear? AB de Villiers, that is the simple logic. Just using this element, you want to make this fellow 0. How to make it equal to 0? This element minus 2 times this element will give you that. That is the row operation, nothing more than that. Am I clear? See, as I told you, if you want complete information, watch it. Or if you understand what I just said, you can continue. No problem. Am I clear? Obviously, my dear friends, concepts are linked. We cannot jump directly to a concept, my dear friends. Okay? At least if you understand this, you can continue. Otherwise, you have to continue from there. That is simple logic. Am I clear? Yeah. Hope you understand. Let me quickly review this topic once again for my de Villiers, because I like de Villiers as a player. Now look here, sir, this is matrix A 2 1 4 minus 1. Here you want upper triangular and lower triangular can be fixed later on. First you have to get this upper triangular, means you need to make this fellow 0. So do row operation to make this 0 using this element. How to make this fellow 0 using this element? It is second row. How can you change? R2 minus 2 times of R1. With this element can be made 0. So what happens? This is 2 1. First row I am not changing, only second row is changed. What is it? 4 minus 4 is 0, minus 1 minus 2 is minus 3. And this is your U, sir. Now if you want to get LU, A is equal to L. L we need to write, U already we got. What you got here by row operation is your U, sir. 2 1 0 minus 3. Hope you understand. Clear, sir. Good. Good, A.B. de Villiers. Now what? This one. Now LU. L means what? This is 1 1 and this is 0. Only this element is required. And how to find this element? You see this operation. We multiplied R1 with minus 2. So this minus 2 means you put plus 2 here. That's it. Hope you understand. Very good. Sai Charan, very good. So let us continue now. For 3 by 3 matrix. For 3 by 3, let us continue the same story. First, let us see same shortcut, Claudes method. Same LU decomposition. Claudes method means main diagonals of upper triangular must be 1. So you have to reduce it to lower triangular matrix. Reduce this matrix to lower triangular using column operations. Reduce it to lower triangular using column operations. Okay. So this is your matrix. Lower triangular means you have to make these 3 fellows 0. But first we have to make these 2 fellows 0, then we have to make this 0. Don't make all of them 0 at a time. First you have to make these 2 fellows 0 using this, then you have to make this fellow 0 using this. And remember, this fellow should not be 0, because using this, how can you make it 0? If it is 0 or if it is 0, that problem will come. Or even after row operation, if this fellow becomes 0, that problem will come. Am I clear? Please remember that. I just quickly repeat. Using this, you have to make these 2 fellows 0. Then there is some modification happens here. After modification, using this, you have to make this equal to 0. Then you get lower triangular readily. Once you get lower triangular, using the operation values, you can find upper triangular quickly, sir. Let us see now. Now this is the matrix. So using this, Using this, make this, but this is already 0, so don't worry about it. Only you have to make this fellow equal to 0. Only you have to make this fellow equal to 0. How to make it equal to 0? Here, column operations. You have to do column operations. Column 2 is column 2 minus 2 times column 1. First do that. So what is the new matrix? We get it. First column will not change. Second column, 2 minus 2 is 0. 3 minus 2 is 1. 1 minus 0 is 1. Because we not changed the third column as it is. Now you made these two fellows 0 successfully. Now we have to make this fellow 0 using this element. Am I clear? So let us see that now. Using this, or we are using circles now, let us use common notation that is good for health. Using this, make this fellow 0. So how to make it? C3 is C3 minus C1. And that will give you your lower triangular matrix, my dear friends. So this is 1, 1, 0. This is 0, 1, 1. And this is 0. 1 minus 1, 0. 3 minus 1 is 2. And this is your lower triangular, my dear friends. You got lower triangular. Just you need to identify what is upper triangular. So let us see. A is equal to lower triangular. Lower triangular we already fixed. 1, 0, 0. Same thing. 1, 1, 0 and 0, 1, 2. And what about upper triangular, my dear friends? Upper triangular we already know main diagonals are 1s because it is Claudes method. These fellows are 0s. Just need to identify 3 elements. Just need to identify 3 elements. First let us clear this. One, two, three. Hope you understand. If you are having any doubts, please do post, sir. Up to here it's clear? Up to here it's clear? Clear, clear, very good. Yes, sir. Good. Thank you. Now, you please tell me how you made this fellow 0. How you made this fellow 0 using this operation. Minus 2. So, at that particular position you put plus 2. Now, please tell me how you made this fellow 0. You not done anything because it is directly 0. So, when it is directly 0, you not done any operation, directly put 0 only. Now you please tell me how you made this fellow 0 using this column operation. And what is the coefficient you used? Minus 1. So you use plus 1 here. And that is your LU, my dear friends. That is your LU, my dear friends. Hope you understand. See, after understanding, take any 3 by 3 matrix. Only thing is, see here, if it is 0, you cannot do that operation. That possibility, that particular conditions generally will happen. Don't worry about it. So you can take matrix, try reducing it to LU decomposition. Either you can use Claudes method or Dools method. Okay, generally Claudes will be used, but it's not a rule, my dear friends. Am I clear? People may use anything. Am I clear? Please remember. That's it, sir. Mathematical concepts are all great. Am I clear? Thank you. Actually, I just given shortcut. I not given how you get this. I'll just try to give you in a nutshell because the complete proof is beyond scope for us. But at least I'll give you the idea how you get this idea. I'll try to give you towards the end once you understand all the problems. Got it? Hope you understand. Now let us take one more problem. For this, we try to do Dools method. Dools method means lower triangular main diagonal should be 1. So we are reducing matrix A to upper triangular matrix. We are reducing matrix A to upper triangular matrix. Upper triangular matrix means what? We have to use only row operations here. We have to use only row operations. Am I clear? So that is the idea. So the idea goes similarly. We have to reduce it to upper triangular. Okay, because lower triangular is fixed here. Lower triangle is 1, 1, 1 and other zeros. Lower triangular is like unit lower triangular we call it. We give a beautiful name for that. We call it as unit lower triangular for our convenience. So you have to reduce it to upper triangular. See, if you want to reduce it to upper triangular, we have to use row operations. Got it? So let us use row operations. So using this, you have to make, one second. There's nothing wrong, but I like to follow conventions. Like using this element, I have to make these two fellows 0. This is already 0. So only you make this fellow 0. Can you give me the row operation for this? Can you please give me the row operation for this? Please give row operation to make it clear. Very good. ABD Villiers, Sai Nivas, very good. See, this shortcut is very rare, okay? Generally, people don't discuss this, okay? Please learn properly. Generally, you may not get this outside. So, I wish you to learn this. Even if you miss the live class, you can try this. Recorded version also you can see and learn this. It is a very interesting, very, very beautiful concept, okay? R3 minus 2 R1, wonderful Sai Charan Reddy. And wonderful Sai Nivas, you people are rocking as usual. Wonderful. So what is it? R2 is R2 minus 2R1. R2 minus 2R1. 1 minus 3, 0. Because this is already 0, so you don't have to do anything, sir. Otherwise, even for this, you have to make row operation. Please remember. If it is non-zero, you have to use row operation. Okay. Now this is 2 minus 2, 0. Now minus 10 minus of minus plus 2, 3, 6. Minus 10 plus 6 is minus 4. And here 2 minus 0, that is 2 only. Now next idea is, using this you have to make this equal to 0. Okay. So you all know what is the row operation for this. Please quickly give the row operation for this. Please quickly give the row operation for this. Wonderful. See, shortcut in live is very, very interesting. Okay, it's like, you know, watching live match. Later on recorded version, see, once, you know, our team wins, watching recorded session also good, but live match and shortcuts watching live is always very, very important. You will be doing first time before others. Am I clear? Please remember this. The fun will be more. It will be more fun. Got it? So what is it? Anyone giving answer? R3 minus R3 is R3 plus 4 times R2. Correct? Now it is 4 times of this. We'll make that equal to 0. So let us see that. 1 minus 3 is 0, 0, 1, 3, 0, 0. Now it is 2 plus 6. Correct only? No? 2 plus, sorry, 12. Don't do mistakes like this. 2 plus 12, 14. Be careful with your calculations, sir. Even I do such calculations or calculation errors regularly, but you have to be careful. Am I clear? Wonderful, wonderful Sai Charan. Wonderful Sai Nivas. Wonderful. So you got your upper triangular matrix. We just need to fix lower triangular. Upper triangular is ready. 1 minus 3, 0. 0, 1, 3, 0, 0, 14. So lower triangular means 1, 1, 1, they are all zeros. You have to fill 3 positions. So you are going to give me the answers for the 3 positions, my dear friends. These 3 answers you are giving me. You are giving me these 3 answers. So you call it as, you know, second row first column element, third row first column element, third row second column element. What is 2, 1, what is 3, 1 and what is 3, 2? You can give me in the order, sir. All the 3 numbers in the order. 0, 2, minus 4. Correct or wrong? Sai Nivas says 0, 2, minus 4. AB de Villiers says 0, 2, minus 4. Now you see AB de Villiers saying that I don't know row operation, but he is solving the problem. I not given Doolittle's method, I only given Claudes method, but he is also answering Doolittle's method. Okay? See, if you understand a concept, or at least you understand what is happening from any place, generally in mathematics, it is possible to understand, sir. You can continue the story. Okay? But only thing is, the missing parts you could able to quickly grasp. Then you can continue from there easily. Very good. AB de Villiers, Sai Nivas, and who else? Who else is answering? Only 2 members. Today weather is not good or what? Why people are not replying? Anyhow, 2 members replied. We should be happy with your efforts. Now look here, how you made this fellow 0, sir? How you made this fellow 0? It is already 0, so you not done anything, so it is 0 only. Very good. Now tell me how you made this fellow 0. What operation you done? R2 minus 2 R1. So it is minus 2 means you have to put plus 2. And how you made this fellow 0? What operation you done? R3 plus 4 R1. When it is plus 4, you have to put minus 4. That's it. And that is LU decomposition, my dear friends, for you. Okay? You learn this method, you can apply. Take any of your previous, hardly we find 2-3 questions only on LU decomposition, but wherever you find, you can answer them quickly just like this. Very easily you can answer it. Okay? So I also given direct method, then I given the shortcut method, the 2 variants also I given. Hope you all understood. Very good, Sai Charan, very good, wonderful. Very good, AB de Villiers, you are following, I like it. Okay? If you follow any concept, it is simple, just like that. You can do just like that, my dear friends. There is nothing in that. Simple concept. Got it? Now if you want to know how, you just need to go little back, but complete proof is beyond the scope, but I just give you the logic behind that. For that, we just need to review our elementary matrices concept. Okay? So I'll just give you that elementary matrices concept and I'll conclude today's class. Okay? Hope the method is clear. The method, Doolittle's method as well as Claudes method. Doolittle means lower triangular main diagonals must be 1, or you can call it as unit lower triangular method. Claudes method means main diagonals of upper triangular matrix must be 1. Just remember this. Nothing more than that. Now, see my dear friend, earlier I discussed 3 type of row operations and 3 type of column operations. See, row operation means what? Interchanging 2 rows, this is 1 row operation. Second type of row operation is multiplying any row with a non-zero constant. Third type of row operation is adding constant multiple of other row. This is what we used in our previous problems, my dear friends. Am I clear? Now, what do you mean by elementary matrix? Suppose I am having identity matrix. Suppose I am having identity matrix. If on this identity matrix, if I perform single elementary row operation, the matrix which is obtained is called elementary matrix. any one row operation you have to do. Any one single row operation, if you do it, the resultant matrix is called elementary matrix. Okay. See, for example, if I do, I am just using third row operation because that is very interesting for me. Am I clear? First two you can try, sir. For example, I do R3 is R3 plus 2 times of R2. Single elementary row operation. And the new matrix which is obtained. What is new matrix? First row as it is, second row as it is, third row will be R3 plus 2 times of R2. So this is 0, this is 2 and this is 1. And this is what we call it as elementary matrix, my dear friends. This is what we call it as elementary matrix. Now you may be asking why this result, what you are writing here and what I am explaining. Okay. So let me explain. Now suppose on identity matrix I performed a row operation, any row operation, and I got this matrix E. On this matrix I performed this row operation, I got this matrix E. Now suppose I am having a matrix A 1 2 3 2 1 5 6 7 8. On this matrix you perform same row operation. On this matrix you perform same row operation, that is R3 is R3 plus 2 R2. Same row operation you perform. See, if you perform this row operation, what happens? 1 2 3. I'll just write it here little down so that you understand better. If I perform, I'll get this answer. How you get it? 1 2 3, first row as it is, second row as it is, third row will be R3 plus 2 times of this, that is 6 plus 4, that is 10, 7 plus 2, 9, 8 plus 10, 18. Now look at this carefully. If you perform this row operation, you get this. On this matrix, if you perform this row operation, you get this matrix. And there is one more way of getting this particular matrix, my dear friends. What you do is, you take the same matrix and you multiply with this elementary matrix on the left of this matrix. You will get the same answer. That is, this effect can be obtained by doing row operations, or you can get this effect by multiplying this matrix with corresponding elementary matrix on left. By multiplying with corresponding elementary matrix on left. Okay, it looks like, you people feel like, this is better, why to do this? If you know this, you will understand how you get the shortcut. If you don't understand this, obviously this is much easier, no? Doing row operation is much easier. Who will do multiplication and get this matrix? I am not asking you to do this. I want you to understand that concept. See, not everything need to be done for solving problems, sir. There are certain things we do to understand the concept. That is, the effect of row operation, single row operation on a matrix can be obtained in a different way. What is the different way? By multiplying the matrix on the left by corresponding elementary matrix. That is, you can get the effect of this row operation on A by multiplying A with elementary matrix on left. That is the logic which we need to understand. Is the idea clear? Hope you understand. All of you able to follow, sir? This is a very, very interesting concept, my dear friends. Hope you understand. That is, the effect of a row operation on a matrix can be obtained in two ways. One is directly applying row operation, or multiplying the matrix on left. Multiplying the matrix on left by multiplying with corresponding elementary matrix. How you get this elementary matrix? By using the same row operation on identity matrix. If you multiply, you will get the same answer. Please verify, sir. You multiply and you can verify this. Okay, now I am not giving time, but after class you multiply and check whether you get this answer or not. Is the idea clear? Yes, sir. Now let us see this. I will just give you. This is the matrix, sir. On this matrix, I want to do R1, R2. That is, I want to swap first and second row. That effect can be obtained See, if you swap first and second row, what happens, sir? This is 1, 3, 5, second row becomes first row becomes second row. And this is 3, 2, minus 2. But this effect can also be obtained by multiplying this matrix on left with corresponding elementary matrix. Is it not the elementary matrix, sir? See, for example, 1, 0, 0, 0, 1, 0, 0, 0, 1. On this, if you do this row operation, you are going to get this or not? So you can get this effect by doing this multiplication on the left. By multiplication on the left, my dear friends. Hope you understand. By doing multiplication on the left. Okay. See, the idea is this. What you are doing, E into A, you are going to get a new matrix. By suppose this is your E into A is there, no? Suppose it is your upper triangular matrix. Suppose it is upper triangular matrix. Then what is A, sir? E inverse into U. And this E inverse is your L, my dear friends. And because of that, you got your LU decomposition method. I am giving it in a nutshell actually. That is actually the LU decomposition outline, we call it. Outline of the proof, we call it. See, what we are doing, sir? We reduce the matrix to upper triangular for LU decomposition. And what was L? It is simply inverse of the matrix. And I given how to find inverse of a elementary matrix. Inverse obtained by third row or third column operation. How you get it, sir? Wherever that constant is there, you replace constant with minus of the constant. And that is exactly what we done. See, my dear friend, you remember, this is your identity matrix. Under elementary matrices, I discussed. On this, suppose I do R3 is R3 plus 2R2. This is your elementary matrix. That is 1, 0, 0, 0, 1, 0. And this is 0, 2, 1. This is elementary matrix. And what is inverse of this elementary matrix, sir? What is inverse of this? If it is obtained by third row or third column operation, wherever the constant is there, you replace constant with minus of the constant. On the first day, I explained this. And that is the inverse of this matrix. And that is exactly what we done for finding E inverse, my dear friends, in LU decomposition shortcut. If you want to understand how, this is how it happens. Is the idea clear? So this is about your LU decomposition, my dear friends. Hope you understand. Any doubts, please ask me, sir. RA. See, RA here I just mean, see, RA means I am just doing, I just use that notation for simplicity, sir. Doing row operation on identity matrix, some particular row operation on identity matrix. It is not universal notation, I just use for simplicity. I just use it for simplicity. To make that statement look simple, I just written R of I means I am doing R, some row operation on I. I am doing some row operation on I. And you get this matrix E. And if the same row operation is applied on A, how can you get this effect? By multiplying with the corresponding elementary matrix on the left. Corresponding elementary matrix on the left. Is the idea clear? Sir, if you have any doubts, please ask me, sir. Okay? So that is the logic, my dear friends. And similarly, what is this elementary matrix? How you obtain this elementary matrix? It is obtained by multiplying second row with 2. Suppose if they give you this matrix and they give you this product, without actually multiplying also you can give the answer, sir. Can you give the answer for this? Can you give the answer? I'll just ask you, because first row is same, last row will be, sorry, not this, I'm sorry, I made a mistake. First row is same, last row will be same. I want only second row here, sir. I want to get the second row here. Please tell me what is second row of this matrix. If you understood, you can give me the answer for this. Directly you can give the answer. I want second row here. What is second row here? What is second row here? Answer. See, I am telling you, these concepts looks very simple and sometimes people ignore this type of concepts, but they are very important, very interesting. That is actually behind the scenes concepts. See, generally in mathematics, whenever we teach mathematics as a tool for engineers. Because for every result I cannot tell you how you get the result, because you are not mathematician, you are an engineer. Okay, so for engineer, mathematics is a tool. Sometimes at least you should know how you get that particular tool, so you can apply it in much better way. See, the way I apply and the way an engineer apply, there will be slight difference, because most of the engineers know the tool but they do not know background stories. Okay, of course I don't say that learn background story, otherwise if you do background story you will be writing GATE mathematics, not engineering mathematics. Okay, so whenever it is possible, try to know background story, then you can write the answers much stronger. That is the logic. Got it? Sai Charan, you are written only 2, 0, 1, no. See, this entire row to be multiplied with 2, sir. This entire row multiplied with 2. 2, 6, 10. That will be the answer. Can anyone give me the answer for this? Can anyone give the answer for this? Here, only first row will be the same. Last row will be the same. Second row changes. You have to tell me what is second row of this result. What is the second row of this result? What is second row? 3 numbers will be there. Please give me the answer. What is second row? Who is giving answer for second row, sir? Second row here. If it is confusing you, I'll just put a bar here. This is different story. This is different story. Got it? Yeah. Who is giving answer for this? These 3 numbers. Sai Nivas given 2, 6, 10. 2, 6, 10. 2, 6, 10. No, 2, 6, 10 is not correct answer. Two, 3, 10. See, my dear friend, how you get this row operation? How you get this row operation? R2 is R2 plus 2 times of R1. From identity matrix, how you get this? R2 plus 2 times of R1. Same row operation, you do it on this. Same row operation, you do it on this. Okay? Okay, I think I made a mistake. Sorry. I was seeing different matrix. Sorry. Then I'm sorry. Let me check this. Yeah. So on this, you do the same row operation, sir. What is it? 1 plus 2 times 0, that is 1. 3 plus 2 times 2, that is 3 plus 4, 7. 5 plus 2, that is 7. R2 is R2 plus 2 times of R1. R2 plus 2 times of R1. 1 plus 0, 3 plus 4, 5 plus 2. That is answer. Why, Sai Charan, you done mistake? Is that clear? See, whatever row operation you done on identity matrix, same row operation you do it on the matrix, you will get the answer. And this effect you can get it by multiplying matrix on the left side by the corresponding elementary matrix. Corresponding elementary matrix. Same story can be generalized even for column row operations, or column operations also, column transformations also. Okay? Same story can be extended for column transformations. Anyone having doubt, please ask me, sir. Anyone having doubt, please ask me. Yes, sir. I am waiting for your answers. Hope you understand. Same story can be done. But here, if you want to get a column operation effect on a matrix, if you want to get effect of a column operation on a matrix, we have to multiply with corresponding elementary matrix on right side. Hope you understand. That is the logic, my dear friends. Okay. So hope you understand. Why clear? No Sai Charan. Why Sai Charan? What is the doubt? Clear, sir. Very good. See, the effect of row operation can be obtained by multiplying corresponding elementary matrix on the left. The effect of column operation can be obtained by multiplying with corresponding elementary matrix on right. That's it. Nothing more than that. If you are having any doubt, because I am running short of the time, so you need to please quickly say that so that I can close this session here. Okay. And on 26th of May, I am starting a session. This is for CS people or people who want to write GATE examination for CS, GATE CS. Okay. And this is how to think recursively. Or recursive thinking. Okay, that would be the title, my dear friends. In this, I discuss the concepts which are related to recursion in algorithms, data structures, C programming, and discrete mathematics also. Okay, so I'll try to take concepts which are related to discrete mathematics, algorithms, C programming, and data structures. It is a general concept, maybe 5 sessions or okay, plus or minus 5 sessions, I'll try to take it, and it is starting on 26th May. On your YouTube channel, I think time is 8 PM, sir. I'll announce this will be announced soon. Okay, subscribe to the channel, okay, and press the bell icon, you'll get the notifications for that. Okay, recurrence relations, yeah, recursive thinking, we'll try to do that. Okay. Recursive thinking means recurrence relations will come, recursive functions will come. Everything is based on recursive ideas only. So we try to discuss that from 26th May onwards. I try to see in how many sessions I can give you the idea for that. It is a general topic also, my dear friends. Don't think it is only for computer science. Those who are interested in problem solving can take up this particular course or this particular topic. Okay, it may look exclusively for computer science, but it's a general problem solving strategy. General recursion is general problem solving strategy, so that I'll be discussing. Sir, say partial differential equations and probability. Okay, I'll try to come up with PDE and probability for sure. Okay, some sessions I'll try to take. If you want any particular topic, you can mention that. I'll try to, because partial differential equations is not there for all the branches. It is exclusively for civil, mainly for civil engineers or those who are going for ESC examination. This partial differential equation is very important. Probability is, for every branch. Probability is important for every branch student, my dear friends. Okay. Next math sessions I'll be announcing soon. So please subscribe, and you can see my recorded sessions on BYJU'S Exam Prep. I think there is 7 days free trial, something is going on. You can just go through the BYJU'S Exam Prep app, download, okay, go through those lessons, my dear friends. For all the branches, engineering mathematics recorded sessions were done by me in a very detailed manner. I try to do all the topics in a very, very detailed manner. It is a visualized content, first of its kind, okay, first of its kind. We try to create, many people, many teams were involved in creating that particular content. Okay, I want feedback for that, my dear friends. Okay, and you can connect for more updates about me in this Telegram channel, where I'll be posting my next updates, my dear friends. Sridhar Dhulipala. Okay, I just recently started this Telegram channel. So you can just subscribe so that I'll give you updates. Maybe I try to post some important information from problems. We'll plan, sir, because I haven't planned things for the live sessions. I'll be coming with more sessions, my dear friends, to interact with you. Okay, that is the main purpose, sir. Eigenvalues tricks also will be discussed. Okay, sure, for sure I'll discuss eigenvalues. That is a wonderful topic actually. Very, very important, powerful topic. Okay, I try to discuss some concepts. Definitely I'll try to see these concepts and shortcuts will be done for some of these mathematical concepts mainly, because mathematics is universal for all branches that we do it. Then as I told you, for computer science, my branch, there also I try to come up with more sessions, my dear friends. Okay, sure. If you have any general doubts, you can ask me, sir. So otherwise I need to call it a day. You have any doubts, please do ask me, sir. I am waiting for your lovely comments. So that's all for today, my dear friends. Have a lovely weekend. Okay, we are already in one of the weekend days, so have a lovely Sunday. Okay, wish you all the best for your examination. Continue your preparation. Stay tuned to BYJU'S Exam Prep app for more information. Okay, that's all for today. Thank you very much. Thank you, sir.